Hello everyone, welcome to an algebra tutorial video learning about domain and range of exponential functions. So just a quick review, domain, when we talk about the domain of a function, we're talking about all the possible x values that we can put into the function that actually work, that we get some value back. Sometimes functions you can put anything in, sometimes you have certain functions that there's limitations on what we can put in for x. If we get an error when we calculate it, that means it's not in the domain. All right, the range, well, that was domain. The range is all the output values we get back for y. So if I'm putting a value in, I'm calculating it out, I get an output value, that's part of my range. And if I describe the range, it's all the possible output values I get back. So domain and range are just describing possible points, all the possible areas that I get points from my function. All right, so we're working with exponential functions. I'm going to look at this particular function here on the left. F of x equals 4.5 times 1.2 to the x power. So we've got the equation shown here. We've got the function in equation form. I've got a table of values put together here. And I've made a graph with some of those points plotted just to help us see three different representations of the function and to understand domain and range a little bit better as we're trying to describe this function here. I use the Desmos graphing calculator. It's available at www.desmos.com. It's a great one. I highly recommend it for any student out there who's learning math. All right, so what do we see? In this function, this thing is growing without bound, right? It's increasing, it's growing. For my y values, it's going to get as high as I want. So we've been talking about this in terms of end behavior. Exponential functions grow very quickly, right? If we're taking exponents and we increase that exponent, very quickly we get bigger. 0, 4.5, 10, 27.86, get up to 60, higher and higher. And you can even see in the table, the bigger the x values get, the much bigger the y values get. So it's definitely increasing, it's getting big on that end. On the other end, as I get smaller in my x values, we've talked about exponential functions always approach a specific value. In this case, my value that it's approaching is just 0 here. I can see that with 4.5. Then it gets to 0.7, then about 0.1, then about 0.01. And if I keep going, you notice that line seems to flatten out and it gets as close as I want to 0. So it approaches 0. And we call that an asymptote. A line, it's just a line that my function gets very close to. So it gets very close to the line at y equals 0. And we draw a little dotted line there to represent that. Okay, so now how does that help me describe the domain and range? Well, remember the domain is all the x values. So if I'm describing the domain of this function, sorry, that looks like an inequality. The domain of this function is, well, what x values seem to work? Well, just by looking at the table of values, negative x values work, positive x values work, 0 works. And if I think about what can I put into that exponent there for x, I can pretty much put in anything. I can put in decimals, fractions, negative numbers, small numbers, large numbers. I can put anything I want. So if I'm describing the domain of this exponential function, it's going to be all the real numbers. It can be anything that's considered a real number. Fraction, decimal, positive, negative, all real numbers. I can put anything in for x, calculate it out, and get some value for a result. And you can see that in the graph. Even though it gets very large and it looks like perhaps maybe 60, there's no value for 60 that I can see. Technically, I could put 1.2 to the 60th power. I'd get a very large number, but I'll get some result. I will get a number. It is possible. Numbers get infinitely as large. So yes, even though it doesn't show it on the graph, 60 would be in the domain, 1,000,000 would be in the domain. All real numbers for x values work. What gets interesting is though when I get into the range. So the range is the y values. And if I just look at this, I get positive numbers, positive numbers. It's very big, but in terms of getting smaller, I get these very tiny numbers, but I'm never, ever, ever going to get 0. And I'm never, ever, ever going to get a negative number, at least not for this specific function. It's going to approach 0. It's going to get very close to 0, but it's never going to reach 0 and never going to get below 0. So my range is all real numbers that have to be greater than 0. Can't equal 0 and it can't be less than 0. But it could be anything that's a positive number. I could also say all positive numbers. That would be another way to describe the range. All positive real numbers. And hopefully that makes sense why to you, why it has to be a positive real number. Because basically I'm taking 4.5, and if I put a positive exponent in, then I'm multiplying it by a bunch of 1.2s and it gets bigger. But if I put a negative exponent in, remember we talked about negative exponents are the opposite of multiplying. So 4.5 times 1.2 to the negative power is basically 4.5 divided by a bunch of 1.2s. But as long as I still have 4.5 being divided by a positive number, it's always going to stay positive. But there you go. There's an example of domain and range. And you can take home that any exponential function is always going to have a domain that's all real numbers. What we need to be careful of is, what is my range? Is it all positive real numbers like in this case? Or are there cases where we need to be more specific about what is my asymptote, what is my exponential function approaching, and that's going to help us find the range of our function.